I am Nikhil, and I would like to welcome you all to this special guest lecture on polymers by Dr. Ajam Sheikh. He is Assistant Professor at MIT College of Railway Engineering and Research at Barshi. I would like to request Dr. Sheikh to come forward and deliver his lecture. Please give him a big round of applause. Thank you, Nikhil. I feel extremely privileged to stand before you all and deliver a lecture on polymers. Let us start with difference between thermoplastic and thermosetting polymers. Thermoplastic materials are types of plastic which become soft when they are heated, and hard when they cool down. This property of polymer is due to weak bonds present between the polymeric chains that can be broken by heat and change its molecular structure. For example, PVC, styrene, butadiene rubber, nylon, polystyrene, etc. On the other hand, thermosetting polymer is a polymer which cannot be softened on heating and hardened on cooling. Thermosetting plastics are highly cross-linked polymers that have a three-dimensional network of covalently bonded atoms. These cross-links shows resistance to higher temperature and hence cannot be softened and remolded. For example, epoxy, silicone, polyurethane polymers. Excuse me, sir. May I ask you one question? Sure, please go ahead. Would you like to comment on compounding of plastic? Sure. Compounding is a process of melt blending plastics with other additives. This process changes the physical, thermal, electrical or aesthetic characteristics of the plastic. Compounding of plastics include binders, fillers, pigments or dyes, catalysts, lubricants and stabilizers. Now, we shall see each one by one. First type of additive is binder. Binders hold other constituents together during manufacturing. Usually natural or synthetic resins are used as binders, which are high molecular weight substances. Second type of additive is filler. Fillers impart better tensile strength, hardness, finish, workability, opacity, etc. to the plastic material. They reduce shrinkage and brittleness. The fillers may be of organic or inorganic origin. Next, pigments and dyes. These impart desired color to plastic. Organic dyestuffs and inorganic pigments are used for this purpose in small proportion. Further, catalysts are also used as binder for compounding of plastic. They are used to increase the rate of polymerization. And lastly, we shall talk about lubricants. It helps during molding operations, especially during lower room temperature molding. The use of lubricants imparts flawlessness and glossy finish to the plastic products. Commonly used lubricants are soaps or esters of fatty acids such as oleic and stearic acids or waxes. Stabilizers help improve stability of the plastic, besides impart rigidity. Very well explained. Thank you. Would you explain to me the process of extraction of rubber from latex? Isoprene is the basic molecule, that is monomer, present in natural rubber. The white liquid, which is oozing out of tree, after incision, is called as latex. Isoprene units are in the form of dispersion, in the latex. Latex is collected and then diluted to make 15% to 20% of rubber and then filtered to eliminate any dirt present in it. It is further coagulated in a tank by adding of acetic or formic acid. After washing and drying, the coagulated residue is treated to make crepe rubber or smoked rubber. Thanks. Would you enlighten us on the process of vulcanization of rubber? Sure. Vulcanization of rubber is a process of improvement of the rubber elasticity and strength by heating it in the presence of sulfur. It results in three-dimensional cross-linking of the chain rubber molecules, that is polyisoprene bonded to each other by sulfur atoms. Vulcanized rubber is more strong and rigid than non-vulcanized rubber. It has many applications and used to make hoses, shoe soles, tire, toys, etc. With this, I would like to conclude today's lecture and express my gratitude for calling me here to deliver lecture on polymers. Thank you so much.